Happy Fry. Yay! We are here for math, and you guys have been rocking it in math all week long with our subtraction action, with our true and false equations. You did amazing with that yesterday. With our part whole, with our whole minus part equals part, decomposing and making 10. You have so many tools in your head to help us with our subtraction. And what we're going to do today is looking at an equation and finding the missing part. Now, if you have your snap cubes, you can use those to help you today. That's what I'm going to be using to model some of the equations for us. You can also use your 10 frames the same way that I use these, right? So whatever you want to use is best. And we haven't used our number line in a while, which is so handy. You'll see the number line in your books, and I just want to reinforce we haven't used the number line in a while. It's always a good tool to have to check, right? Maybe we want to check that our equations are true. So, with our number equations, right? If I'm doing addition is part plus part equals whole, right? Like Michigan's family. There are two boys, Jack and Thomas. That's my part, right? 2. The other part is Mr. and Mrs. Egan. The other part is 2. And all together, the whole is 4. Right? And that's no different from me looking at the number 4 and decomposing it. Right? You guys remember our number bonds. Decomposing is really the same way as breaking apart numbers. Addition and subtraction are just taking that number as a whole and decomposing it in different ways. So if I'm looking for a missing part in an addition sentence, this part could be the missing part, this part could be the missing part. And I'm going to use whatever part I know to figure it out. Like I might give you guys a riddle. And I might say, Mr. and Mrs. Egan have some kids. I'm not going to tell you how many. I want you to find out. But we have 4 members, our entire family. How many kids do we have? Well, if Mr. and Mrs. Egan is one part of the family, and there's 4 members in the whole family, I'm going to decompose that number into one part and the other part. Right? Or I could write it as a subtraction sentence, right? The whole is 4. Subtraction is whole, take away one part, gives us the other part. So 4 minus 2 equals 2. So we're going to be looking at some addition and subtraction sentences today, and the part is going to be missing. And it could be this part, it could be this part. In subtraction, it could be this part, like what we're used to solving, or it could be this part. And it's just a good way to recognize, right? If we know our fact families, then we know that this is the same as saying this. And this is the same as saying, switch my parts. That, right? That would be the fact family for 2 and 2 and 4, right? With the missing parts, of course. So, let's get ready to dive in and find some missing parts. If you have your book, we're working on page 367. 300s, 6 10s, 7 1s. Okay. Becky feeds 7 chickens. That's something I know. I want to remember that. And some ducks. We don't know how many, but some. She feeds 11 animals in all. How many ducks did Becky feed? So, what do we know? In all tells us that's the whole, right? In all. Whole, one of our vocabulary words for the weekend reading, right? Whole means the entire or all of something, right? Remember Toad kept saying, in the whole world. Well, in this equation, the whole that we're looking at is 11. And we know one part, she feeds 7 chickens. How many ducks does she feed? Well, we can solve this as an addition sentence, right? Part plus part equals whole. Or we could write the related subtraction fact. Whole, take away part, equals the other part. So let's use our snap cubes to help us find out. So I have 10 green, right? I have 10 and one more. I know that makes 11. So that's my whole. And that's my whole. Here's my part, here's my part. I'm going to take away 7 and see what my other part is. Ready? 1, 2, 3, 4, 5, 6, 7. So that's my whole. Here's one part. Here's my missing part. 1, 2, 3, 4. Is 11 minus 7 4? And is 7 plus 4 11? That sounds like a correct fact, family. But guess what? I want to check. And I want to check using my number line. Here's 7, here's 4. Now, do you remember how we use our number line when we're doing part and whole? So we start on one part. So let's say we were finding out 7 plus what part equals 11. Okay, so when we're using our number line to find out, we start at the known part, right? We start here. However many hops we do is our missing part. I'm gonna do that. That's our hops. Our whole is where we stop. Okay, so I'm going to start in 7. I didn't put 7 on my number line. All right, I'm starting at 7. Ready? 1, 2, 3, 4. I stopped at 11. I started at 7. 1, 2, 3, 4. So, with my number line, did I confirm that these equations are true? Absolutely, we did. Woo! Rock on, first grade. You did amazing. Okay, let's jump right into problem number 1. Rewrite that. Okay, number 1. Now, I know they have these here for you for traceable, so we're just going to go through them. I'm going to show you how we're checking on our number line. To remind you how we use that number line, right? 17 minus equals 15. So remember, subtraction is whole, take away part, equals part. They wrote the traceable 2 in there for us. But what are we going to do? Let's make sure it's true. Let's make sure the book is not tricking us. So whole, take away part, equals part. For my number line, I'm always going to, when I'm counting up on my number line, I want to start with the biggest number. Of my 2 parts, start with the higher one. That means less hops, right? I don't want to start at 2 and hop up 15 times. I want to start with, and I mean, if it's the part you know, that's what you have to do. But when you know both parts and you're checking, start with the higher part, okay? So, I'm starting at 15. I'm hopping 2 times. I'm stopping here. This is where I start. This is how many I hop. I'm stopping here. If it works out correctly, then this sentence is true. Ready? 1, 2. Is this equation correct? Yes, it is. Absolutely. We know that 17 minus 2 equals 5. Okay, the book didn't trick us. Let's go on to number 2. They have 3 plus 9 equals 12. And that's our missing part here, right? Plus 9 equals 12. Well, I'm going to write my subtraction sentence and see if it makes sense to me, a related subtraction sentence. Here's my whole. 12 minus 9 equals, here's my unknown, right? 3. Does that make sense to you? Let's see, if I start here, here's my part, and I'm going to hop this many times, I should stop here, right? 1, 2, 3. Was it correct? It absolutely was. Okay, number 3. And then we're really grooving. 15 minus 3 equals 12. Or related addition sentence, part and whole, right? 12 plus 3 equals 15. That sounds correct. That sounds correct, but let's make sure they are true. I'm going to start on this number. I'm going to hop this many times. I should stop here. Ready? 1, 2, 3. Is it true? It is true. You got it. Okay, now for some hard math. Now we're using our manipulatives this time. They don't have the number there for us to trace. We're going to use our brains and our manipulatives and our number line to make sure we are correct. Okay, number 4. 14. Use my blue. I want you to see what I'm writing here. 14 minus unknown equals 12. Now, just so you guys understand what this looks like, right? This is my whole. Here's my missing part. Here's my known part. We are so used to solving when we do addition for the whole. When we're doing subtraction, we are so used to solving for this whole. But all it means is I switch these parts, right? This number sentence is no different. It's related to this number sentence, right? These guys are the same. They're related. We just don't know the missing part. So let's find out. If you're using 10 frames, fill up a 10 and then 4 more, right? Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 of my greens and I have 4 purples. So I have 14. That's my whole. I'm going to take away the known part or follow this subtraction sentence, right? 14, if I take away this part, it will leave me with this part, right? So what am I going to do first? What's one of our strategies? Make 10, right? If I'm taking away 12 from 14, look at that 1. I know 12 is 10 and 2. So I'm going to take away my 10. And I'm also going to take away 2. So here's 12. What do I have left? 2. Is 14 take away 2, 12? And 14 take away 12, 2? Well, here's 12. Here's 2. I can solve with a related addition fact, right? 12 plus 2 equals 14. 12, 13, 14. And also on my number line, I could start here and I can stop here. And this will tell me how many jumps, right? So let's start at 12. 1, 2. All of these equations are true. We solved for that missing part. And I bet you guys knew that really quick out of your brain, easy peasy, because 12 is only 2 less than 14. So thank you for working through that and strengthening your number sense, okay? All right, number 5. Blank plus 1 equals 10. Now, the same thing I did the last time. I know we are not used to seeing number equations like this, but let's slow down. We know addition is part plus part equals whole. So let's make this into a subtraction sentence that we're a little more used to seeing. Whole, take away part equals another part, right? Minus 1 part equals the unknown part. Well, 10 minus 1 equals what? 9. Yeah, see, when we look at it like this, it makes it a whole lot easier to answer. So don't be scared to take a fact and switch it into a related fact. You know part plus part equals whole. You know whole take away part equals part. Let's solve on our number line. So I am at, what I do know is blank plus 1 equals 10, right? And I think it's 9 plus 1 equals 10. I want to solve to make sure. I'm going to check to make sure, right? That it's true. I'm going to start at 9. I'm going to stop at 10. This should be how many hops I do. Boop. Absolutely. Easy peasy, that one. Don't let math equations, the way they're written, confuse you, right? Remember, horizontally, vertically, if that whatever side, right, that equal sign just means that this side of the equation is the same as this side of the equation. Don't get tricked. Math is so much fun. It's so easy. Your number sense is so strong. You guys rock it. Number 6. 14 minus unknown equals 8. So what do I know? I know my whole is 14. I do not know this part, but I know this part. So let's go back. We had 14 counters, right? I have 14. I don't know how many is this part, but I do know this part. So if I show this part, I will be left with this part. So let's take away 8. 1, 2, 3, 4, 5. Oh, you know what? Guys, by looking at this, it reminded me, I know 8 is 4 plus 4. So I know I can take away this first 4. Easy peasy, right? And I made 10. Now I have to take away another 4 to finish that 8, right? 1, 2, 3, 4. So by making 10, I broke it apart into, here's my 8, and here's what's left over. 1, 2, 3, 4, 5, 6. 14, take away 6 is 8, right? Here's my 8, that's that part. Here's my 6, that's that part. And the whole is 14. I have 10, 1, 2, 3, 4. But let's check on our number line to make sure. I'm going to start here. This is how many hops. This is where I stop. Ready? 8. 1, 2, 3, 4, 5, 6. We were correct, guys. Awesome, awesome. You are rocking this. Math is so much fun. I know sometimes it's a little hard, but it is so much fun. Okay, we are already on number 7. 9 plus unknown equals 18. Well, wait a minute. I know my doubles facts. 9 plus what equals 18? Maybe if I write it this way, it'll make it a little more sense for you. 18 minus 9 equals, right? These are related. What is it? Oh, I can hear you guys shouting because it's a doubles fact, right? 9 plus 9 equals 18. Or is it jelly bean? That's right. 9 plus 9 equals 18. Jelly bean. That means 18 minus 9 equals 9. But you know I want to check, right? So I'm starting at 9. I'm hopping up 9. I'm going to stop at 18. All the way over here. Starting here. Let's see if I do 9 hops to check. 1, 2, 3, 4, 5, 6, 7, 8, 9. These equations are true. Ding, ding, ding. They are true. Okay, guys. We are moving along here. See those doubles facts, making 10, all of these things help us to see our number equations, right? They help us. Number 8. 15 take away blank equals 10. Well, I just talked about this, right? Making 10 is such a strong point of yours, guys. You are so strong with your number sense within 10. So this equation is the same thing as saying 15 take away 10 equals, well, you know that because this 10 is what this is the value of, right? So if I take that value away, what am I left with? 5. You're right. But 15 minus 5 equals 10. Does that sound right? 15 minus 10 equals 5. That sure sounds right, but let's check to make sure it is true. Let's make sure it is true. And one way we can do that is by looking at our tens frames, looking at our snap cubes. I have a full 10 here. My greens are 10. My purple is 5. 10 and 5 It's 15. Part, whole. 15. I see that so well in my number sense. All right, and we are on to number 9, guys. Blank plus 12 equals 14. Missing part plus part equals whole. Now, I know this looks a little weird. We're not used to that first number being gone, right? But this is just a part. So think about what all of the related facts could be. All right, it could also be 12 plus blank equals 14. Those are the 2 related addition sentences. If I made it a subtraction sentence, part plus part equals whole, it's going to be 14 minus part minus 12 equals unknown, right? Maybe that's a little easier to solve in your head. This is the same thing as saying this, right? This is just showing part and whole, and this is showing whole, part, and part. It's just different ways of saying that this side of the equation is the same as this side of the equation, right? It's just showing our number bonds in different ways. So 14 minus 12 equals what? Let's solve this easy peasy. Here is 14, right? I have 10 greens and I have 4 purples. I know 10 and 4 makes 14. If I want to take away 12, well, first thing I'm going to do is decompose that 12 into the numbers 10 and 2, right? Because if I can take away 10, that's easy for me, right? Then all I have to do is take away 2 more. And what am I left with? Here's my whole. Here's 14. Whoops. Butterfingers, Miss Egan. Here is my 12, my part. And here's my missing part, 2. Is 14 take away 12? 2? Yeah. And is 2 plus 12 14? Yeah. Let's check on our number line. Ready? This is where I'm starting. This is where I'm stopping. This is how many I'm hopping up. Ready? 1, 2. You guys are so smart. Look how, I know this subtraction work has seemed really hard, but I bet today it's all clicking. It's all coming into place, right? You worked so hard. All right. Guys, that was the last problem on that page. Turn the page and go to 368. And we're going to do the first 3 problems, 10, 11, and 12, the same exact way. Okay? Missing part, minus 4. Oh, I'm sorry. It's a subtraction sentence, so that is not missing part. Whole minus part equals other part. It's our subtraction sentence, so we don't know the whole. Our whole is missing. Minus 1 part gives us another part. So, if I don't know this, what's an easy way? What number sentences are easier for me to think about in my head when I know the parts, right? Part plus part equals whole. 15 plus 4 equals whole. Well, I start on 1 part and I count up that many times, and this is where I stop. Ready? 15. 1, 2, 3, 4. 19. 19 minus 4 equals 15. Or 15 plus 4 equals 19. Well, let's check to make sure that's true with our counters. I have 14, 15, 16, 17, 18, 19. Okay. So I have 10 greens, right? I have 10 greens. I have 9 purple. 10 and 9 together, I know, make 19. if I take away 15, which I know I can do by making 10, right? 15 is 10 and 5. 1, 2, 3, 4, 5. So I made, first I found 10 and took that away. There's 15. Here's my whole 19, right? I took 15 away. I am left with 4. 4 and 15 are my parts. Is that correct? And I put them together and I get 19. These number sentences are true. They are, they are. You are rocking it. Okay. Number 11. 5 plus blank equals 13. Well, what do we know? Here's our whole. We have an unknown part and a known part. So let's make it into where we're used to starting with the whole, right? 13 minus known part, we know, equals unknown part. So this is a related subtraction fact. 13 minus 5 equals what? Let's use what we know about making 10. I know 5 can be broken down into 3, it's a subtraction sentence, and 2. So 13 minus 3 is 10. 10 minus 2 equals 8. Let me show you how I did that, right? We started with 13. And I'm taking away 5, right? But I know 5 can be broken into 3 to make 10. And then I still need to take away 2 more, right? So I have 13. And by taking away 5, I'm taking away 3 and then 2 out of 10. Okay? So that leaves me with 8. Is our missing part 8? Absolutely. Absolutely. We solved it by making 10 and then we checked it with our counters. 5 and 8, 1, 2, 3, 4, 5, 6, 7, 8 makes 13. 13. All right, guys, number 12. 17 minus blank equals 14. 17 minus part equals other part. So if I ever see an equation like this, it's the same as me seeing this. 17 minus 14 equals, right? These are both parts in my subtraction sentences, right? If I know this is true, then I know this is true. So 17 minus 14 equals what? Here is my part. I'm going to use my number line. I'm going to start here. I'm going to stop here. However many hops I do is my missing part. I'm starting at 14. I'm stopping at 17. Ready? 1, 2, 3. 17 minus 3 equals 14. Well, let's make sure that's correct. Here is 17. I have 10 greens and 7 purple. 1, 2, 3, 4, 5, 6, 7. 17 minus 14. Well, what do I know about 17 and 14? What do they both have? They both have a value of 10, right? So if I'm taking away 14 out of 17, I'm taking that 10 away. Part of my 10 already fell. If I'm taking 14 away from 17, I'm taking that 10 away, right? And now I'm left with 7. So now my number sentence is 7 minus 4. 7, take away 4 is 3. Does that confirm that that's right and that those hops are right? It does. And look, here's our one part, 14. Here's our other part, 3. And here's our whole, 17. Wowie kazowie, guys. I am so proud and impressed let's problem solve number 13, and then you're going to do the next page all by yourself, okay? Now remember, when we problem solve, we have to read, we have to plan, we have to write and solve, and when we solve, we're making sure those equations are true. So, Mario uses 6 red beads. All right, 6, that's something we know. And some yellow beads. All right, we don't know how many yellow. He uses 17 beads in all. Oh, in all is telling us that that is the whole. How many yellow beads did Mario use? So 17 is our whole. The 2 parts are 6, and we don't know what. Write a subtraction equation to solve. So in our subtraction equation, it is part, take away part, equals other part, right? 17 minus 6 equals what? How can we use this? How can we solve that answer? Well, if I have 1, 2, 3, 4, 5, 6, 7. Here's 17, right? I know it's 17 because I have 10 greens and 7 purple. I'm going to take away 6. I know 7 take away 6 is going to leave me with 1, right? If I'm taking away from that 1's place. 6 is 1 less than 7. And that 10's is going to stay there, right? So I still have my 10 and I have a 1. So 17 take away 6 is 11. Let's write this as a related addition sentence. If this is whole minus part equals other part, what would my related addition sentence be? Yeah, I heard some of you saying 6 plus 11 equals 17, or 11 plus 6 equals 17. And to solve that, right, I'm going to go back and do 11 plus 6 equals 17. Or I can use my number line. I'm going to start at 11. I'm going to start here, right? Start at the bigger part that you know. I'm going to stop at 17, and I'm going to hop 6 times. Ready? 1, 2, 3, 4, 5, 6. These equations are true. Oh, man, guys, what awesome work today. On the next page on 369, I want you to do problems numbers 1 through 6 all by yourself and then send them to me. Whew. And then, guys, it is Friday. You did awesome subtraction action work this week. Give your brains a kiss, and I'll talk to you later.